All the parameters are divided into groups. The first group is called constraints, and the first parameter of this group is level. Earlier, we saw the conditional level in the family editor. In the project environment, in model space, there are also levels. They are required to attach other elements at an elevation. As well as in the family editor, in the project levels can be seen on the elevations or sections. Levels can't be displayed on views, such as floor plans, because the level planes are parallel on the floor plan planes. Let's move on to the facade. I expand the elevations rollout and open the north facade. Here we can see two levels. These levels were created inside the project template. We can create additional levels, as well as delete extra ones, but these should be done sensibly, since when the level is deleted, the objects attached to it will also be deleted. Just like in the family editor, the bottom of our cubes coincided with the level. This is the way it happens in the project. So, in family editor, we are demonstrating the situation that will exist in the project. All our cubes were attached to level 1 as we place them on the floor plan, which in its turn is associated with this level. You can check the attachment of the plan to a specific level. I will switch to the floor plan and find the associated level parameter in the view properties, where level 1 is set. Some plans can be attached to the same level simultaneously. Let's go back to the facade. Select one of the cubes again and change the value for the level parameter. After I remove the mouse cursor from the Properties panel, the cube will jump to level 2. Now it has a different attachment. Besides an exact reference to the level, you can also set a displacement with a negative or positive value. If we do this, we will see that the cube will be displaced from the level. A negative value for the elevation from level parameter will remove the cube lower from the level. In this case, this offset is the displacement of the cube from its original position, relative to the conditional level inside the family editor. That is, if in the family editor the cube were displaced from the conditional level, the value of the parameter elevation from level by default would still be equal to 0 in the project, since a family is not only the geometry of the cube, but an object which may contain a number of geometric bodies, some of which, or even all of them, can be displaced from the level in the family editor. But it's considered that the family itself doesn't have an initial displacement from the level. This feature of Revit is convenient for creating families such as sockets, switches, or windows. During placing in a project, you place them with reference to the level, but the geometry within the families is initially displaced. That allows us not to think about displacing instances of such families when we work on a project, except the cases of non-standard displacement. Also in Revit, you can set an incorrect offset for objects. For example, let's select the cube attached to level 1 and give it an offset greater than 4 meters. Then, visually, the object will be positioned as if it's linked to level 2, but in fact, it will remain its link to level 1, which will be a problem if we want to create a quantification of cubes located at level 1. This cube would also get there, although physically it is at level 2. The host parameter records the work plane on which the object is located. The level is often the work plane. This parameter serves only for information purposes. Its value cannot be changed. The parameter moves with nearby elements, is responsible for the fact that the object will move together with the displacement of adjacent walls. That is, if there was a wall next to our cube and it would move, in the case when the moves with nearby elements parameter is activated, the cube would move subsequent to the wall. I will demonstrate this. Go to the floor plan and select the wall tool from the Architecture tab. I will create an instance of the wall. To complete the command, press the Escape key twice. If I move the wall, the cube won't be removed with it. But if I select this cube and change the value of the Moves with Nearby Elements parameter, then I move the wall, the cube will follow it. I will delete the wall and return to the facade. The parameters height, length, and width were created by us. Therefore, they don't require any explanation. The volume parameter is calculated automatically for those families whose geometry is simple enough to calculate and doesn't consist of many separate geometric bodies. For more complex families, the volume parameter will not appear in the Properties panel. There are three parameters that are collected in the Identity Data Parameter group: Image, Comments, and Mark. So, Comments and Mark, these are text parameters. Any random text can be written in for their value and displayed in tags or in schedules of building components. And the image parameter is one that has a picture downloaded in its value. This picture can also be displayed in schedules. Two parameters in the phasing group are also required for any model object. These parameters are used to create models of the renovated buildings. If our project is the one of a new building, then the values of these parameters should be left without any alteration. Close the facade and return to the floor plan. Select the random cube again and try to change the value of the length or width parameter. We see that the cube has been changed. Likewise, you can change any of these cubes. In this case, all changes are carried out for each cube individually. Note also that the Properties panel doesn't have the Material parameter that we created inside the Family Editor. This parameter is hidden in a separate window that can be opened by clicking the Edit Type button on the Properties panel. In the Type Properties window, we will find the Material parameter and a number of other parameters. The parameter Cube Material is present here because, when creating it, we set the Type option. At the same time, when we created the parameters height, length, width, we selected the Instance option. Thus, if the Instance option is selected when creating a parameter, then such a parameter will appear in the Properties panel. If the Type option is selected, then we'll see this parameter in the Type Properties window in the project. But that's not the only difference between type and instance parameters. But before we get into the true meaning of this separation, let's look at the parameters and the Type Properties window that we didn't create ourselves. Just like the parameters Image, Comments, Mark in the Properties panel in the similar group Identity Data, these parameters are required for any model objects and serve to display the data specified in their values in the schedules. Moreover, a family may have additional standard parameters that depend on the category of that family. Let's have a look. I will close the Type Properties window and return to the Family Editor. If you already closed the Cube Family file, select any instance of the cube and press the Edit Family button on the ribbon. In the Family Types window, we see all the parameters of the family, but they differ from the set that is in the project. For example, there are no parameters, level, host, and a number of others. The fact is that only a specific instance of the family can have these parameters, but not the family itself. Let's see how changing the family category will affect this list of parameters. To do this, open the Category and Parameters window and change the category, for example by selecting Doors. Let's make sure that the list of parameters has changed a lot. Some parameters remain the same, but new ones were added. That is, the category directly affects the presence of certain standard parameters in the family.